Are you able to like view my iPad screen now?
Yeah,
Okay,
but
perfect. So I'm
it
just gonna like dive straight into the question. I posted these questions on the announcement as well, but I'm just gonna like explain the question first, like conceptually, maybe draw a diagram, and then like we will like solve the question. So first, just let's begin by reading the question,
oh,
right?
with the recording, it says that I can't record to the cloud because you are.
It does say that. Okay, then I'll just record to the cloud, and if it gets corrupted, it gets corrupted, I guess.
Okay.
It should be fine because I mean Zoom is pretty much on top of things. I just wanted to do it as a safety measure, but should be fine.
Mhm.
Anyway, so let's just begin by I'll just read the question first. So the question says, suppose we have an array to store all of the holiday presents we have purchased for this year. Now that the holidays are over and all the presents have been given out, we need to delete our list. An array is a dynamically allocated array of structures that contains the name of each present and the price. The name of the present is a dynamically allocated string to support different lengths of the strings. So that makes sense because if it were static, then we would have to declare different sizes. So that's why it's a dynamic array. Write a function, write a function called delete present list that will take in the present array and free all the memory space that array previously took up. Your function should take two parameters, the array called present list and the integer num representing the number of presents in the list, and return a null pointer representing the now deleted list. Note that the array passed to the function may be pointing to null, so that's the case, should be handled appropriately. So now I'm just gonna like explain the question conceptually, what it's asking. So we have an array, right? We have an array called present list. Let's say it has one, two, three. So it has 0, 1, 2, 3, 4. These are the indexes, and it has five elements, right? Each element, since it's an array of structures, it contains two members. So it contains two members. One is a character array called, let's just call it PN, meaning like present name. And then the second one being a float, which would represent the price of this um, present, right? So who is pointing to this array? Since this whole array is dynamically allocated, we have a pointer called present list. I'm just gonna call it p list is pointing to this array, right? So what we need to do is we need to free all the associated memories with this array, and then at last we need to free this plist as well. So it is given to us that, hey, that this character array at each index will also be dynamically allocated. So we have to also keep that in mind because if I just say, and then if I just say I free this, all this like at each and every index, the character present array will still not be freed, right? So what we need to do is we need to loop through this whole array, um, go to each and every index, and then free this character array manually. Once we have done that, we can free the present. Oh, sorry. Once we have done that, we can free the present list itself. Hopefully that like the conceptual part of it made sense. If you have any questions, please do let me know. No? All right, perfect. So also in the question it says that the present like the so for example like our function is struct present pointer, let's call it del delete p, meaning like delete present, and it takes the two parameters. So it takes the struct itself, struct it takes a list of presents. Let's call it present star. Let's call it pl, meaning present list, and int num, meaning how many like num essentially represents like how many presents we have in this list, right? So that will help us to iterate over this present list and like make sure that we're deleting each and every element appropriately. Also, in the question, it says that there might be a case that the list passed to this function as a parameter might be already empty, right? So it might already be null. So we have to make sure that in our function we are checking if the present list is already empty. So a simple way to do that is just a simple if statement. We can just say if PL is already pointing to null, then I can just return null, right? So hopefully that makes sense. So like for example, if the list that was passed to this function, or just in case it was already pointing to nothing, right? Just like the user before us like freed all the associated memory, we have to like write a like an edge case for that, and that's like the simple edge case. Like if the present list is already null, meaning it is pointing to nothing, I'm just gonna return null to the function, right? Because that's what we have to do at the very end. Now what I want to do is I want to loop through this whole array, go to each and every index, free the character array, and then once I've done and once free the character array because it is a dynamic character array. Once I've done that, I will come back and I will return the pointer PL itself, right? So I'm just gonna run a for loop for int I equal to 0. I is smaller than num. Num here represents like the number of the number of items there are in the list. And then I plus plus. Now I will go to each and every index. So I'll say PL at the ith index dot present name. I'm just gonna call it P name. Uh, I'm just gonna free it, right? Does that make sense? So I'm going to each and every index, freeing the character array. Once I'm done that, once I've exited this for loop, I'm gonna free the pointer that was essentially pointing to this whole array. So I'm just gonna call free PL. And once I'm done, I'm just gonna return null to the function. Did that make sense? It's a pretty straightforward question. Uh, I just wanted to cover this question first because it will give you like a good starting point of how we free memory, because you can't really just free memory. Like let's say this is a pointer that was pointing to this like dynamic array, right? You can't just free it because if you just free it, you will lose all the connection to the character array that was in here, and this will cause a memory leak. So that's why we have to go to each and every index, free the character array, which was dynamic. If it was static, let's say, for example, if the structure said instead of, as you can see, the struct present has character star present name, meaning it is a pointer. If that was a static array, meaning like it was something like char uh, this, then I wouldn't have to free it because the static memory, it destroys itself. So that's one thing to keep in mind. If you do you have any questions on that?
No.
Perfect. Anything? Let me know because we don't have anyone here, so it's pretty much one-on-one uh office hours. So there's like no need for you to be like, you can ask any question honestly, because DMA is like one of those topics that a lot of people struggle with. So I really wanted to like people practice the past FE questions because especially if you're CS, you're probably gonna have to take the FE, and the questions will be on the similar level as this one, or maybe even harder. So yeah, no more questions?
Can you repeat what you said about freeing the memory to like prevent memory leaks?
I don't think I can hear you well, but give me one second. Say that again, sorry?
Can you repeat what you said about freeing the memory to prevent memory leaks? Like what was it that caused the memory leak? Like would
Okay,
cause.
okay. Let me draw a new diagram, okay? Let's say we have a present pointer called PL, right? This is the present list, and it is pointing to an array, a dynamic array uh of type present, right? So like something like that, right? So each and every like index at each and every like index, we will have two members, right? As you can see in the struct itself, it has the present name, which is a character string, and then we have the price. So for example, so this character star, let's call it p name, right? And then we have a float price. So this right here is a dynamic memory itself, right? So if I were to like, let's just say when you free memory, you just call the free function, right? And you might think, hey, I'm just gonna free this memory here because this pointer is essentially just pointing to a dynamic array of type present, right? So if I free this, it would destroy this whole memory, but this character p name, it will still exist somewhere in memory, right? So whenever you free memory, you have to free the memory from within. So at any point, there's a dynamic in a struct. If there's like something like a dynamic memory, you have to go to that uh, index and then free that dynamic memory here and keep going, keep going, keep going, free this, free this, free this, free this. Once you have hit your limit, once you have hit the very end of this array, you can now go back and then free the memory here. That makes sense?
Yes.
If you still don't understand it, like I have one more question after this one where I'm gonna cover like freeing memory. I have two questions for how to free memory appropriately and three questions to like get like a basic understanding of DMA. So hopefully that makes much more sense as we like keep going forward. All right, so that was the first question. The second question is this one. This is just like this question builds up on the question that we covered, like the present list, but it is a lot more like complex, if you will, because now if you can see in the you can see my screen, right?
Yeah, I see the question.
Yeah, so now if you see the structure itself, now it has four members. It has a character sentences, which is a 2D array, 2D dynamic array. It has a number of sentences. We don't need to free this because the int num sentences is static, right? And then we have character title, and then we have character author, and these two also are dynamic memory. So the same logic will apply here. We would need to like free from the within,
Are
like
you
we need to go,
writing?
huh?
Are you writing?
No, 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 I'm not writing. I'm just like explaining.
Okay, I just thought maybe I wasn't seeing it.
No, 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 no. I was just like trying to explain it conceptually, but um, so the same logic applies here. You would need to like go to each and every index, free that specific memory, and then move forward. So let me draw okay, let's read the question first. I'll draw a diagram, explain it conceptually, and then we will move on to the coding part of it, right? So the question says, complete the following user-defined function definition that properly deallocates all memory associated with the heap space of the struct type book T. The parameters of the functions contain reference to heap space of where the array of book T is stored. Along with the total number of elements as number of books. Note that within each type book T, sentences is a array of book T sentences is an array of num sentences strings where each string was dynamically allocated as were the string title and the author. So it tells us in the question that hey, the character 2D array sentences that is dynamic, the character title array that is dynamic, and the character author name author is also dynamic. So we would have to like again the same logic applies here, like go to the each and every space and then free the memory from within. And once we have done that, I can just free as you can see book T star library. So let's just write the function prototype first. Actually, let me just explain what the question asking. So we have a pointer called library, right? So what is a library? Library is just a collection of books, right? So that's what the question is asking us. Hey, you have a library. Library is just a collection of books. What I want you to do is deallocate all the space associated with the library. So library is just a collection of books, as you can see. So we will have an array, right? One, two, three. Let's just say these are the indexes 0, 1, 2, 3. And actually, let me draw a bigger diagram because we have a lot more members this time. So something like this. One, one. Okay. So each and every index, so the index is 0, 1, 2, and each and every index we have members, right? Since it's a library type or it's a book type array, and it's a sorry, it is a book T type of array. At each and every index, I will have four members as specified in the structure, right? As you can see, it has so each and every member is each and every index will have four members, and it will look something like let's call it char star star. For sentences, I'm just gonna write S, and then it will have int number of sentences. I'm just gonna write ns, then a char star title, and then char star author, right? And this would be like one book. This would be book two, book three. So we have to like go to each and every index and then free this, free this, free this. But the tricky part here is this is a 2D array. So this itself will also point to character pointers, right? And each and every character pointer will point to a character array of like the actual sentences the book has, right? So hopefully that makes sense. If you can, do you have any questions on this diagram?
No, I'm fine.
No? Okay, perfect. So what we need to do is go to each and every index, free the associated memory, and then once we're done with it, I'm just gonna come back and free a library itself. So let's write the function prototype, void clean. I'm just gonna call it clean, but it says actually clean up, whatever. But book underscore t star lib, and then int num books. I'm just gonna call it nb, meaning number of books this library has. So I'm gonna run a loop on this outer array first, right? So I'm just gonna say for int I equal to 0. I is smaller than the number of books, I plus plus. That pretty simple, right? I'm gonna run a loop on the outside one. Now what I want to do is uh I want to run a loop at this level, right? Because I want to go to this box, I mean this member here, go to this member and then free this memory, right? So since it's a 2D array, I would have to like run a nested loop. So I'm just gonna do for int j equals to 0. J is smaller than library at the jth position dot the number of sentences. Let's call it ns j plus plus. This might be tricky. This might be a little tricky for sure because so as you can see in the structure itself, the int num sentences represents like how many sentences each book has, right? So I'm gonna run a loop on that level, uh, and then I'm gonna free all the associated memory at that position. So I'm just gonna say free library at the ith position dot sentences at the jth position, right? So at the first, like the very first, it would go 0 here, and then it would go 0 here, and then it would free this. It would go 1 here, it would free this, go 2 here, free this, go 3 here, and free this. Once we have done that, we're gonna exit the inner J loop, and just I'm just gonna free. the I'm gonna free the title itself. So lib dot I mean lib at the I position dot title. Oh, free lib at the I position dot author, right? Once I've done that, and then I'm gonna do free lib I dot sentences once, and then I'm gonna free the library itself. That's a little bit tricky, so that's why I covered the first question first. Uh, any questions? Please do let me know.
No, I understand this.
You understand or don't?
I understand.
Oh, you understand? Okay, perfect. Yeah, this some people might find it tricky. So yeah. So yeah, so I'm gonna just keep note like I'm freeing the title, freeing the author, and then at the very last I'm freeing the sentences because hey, I because okay, let me just do this for YouTube. Because let's say each member has sorry, each structure has a member, char, star, sentences, right? So how, let's visualize it, how it will look like in memory. Let's just visualize it for like our own sake, right? So it would be a character array where each, first of all, it would be a character pointer. Each and every index would be a character pointer. So sentences will point to an array of character pointers, and in turn, these pointers will point to a array of characters, aka a string, right? And it could be anything like A, B, C, D, same for here, same for here, same for here. So what we want to do is I want to free this memory first. Then once I'm done with it, I'm going to free sentences. So that's why we have the inner J loop, like the nested J loop. So I can run a loop at this level. Then I can run a loop at this level, free this memory, uh, continue on for each and every index, and then free this memory. So hopefully that makes a little bit like much more sense than this one. Questions? No questions? Good.
Yeah, I'm good.
All right, perfect. Uh, all right, so this is the third question. I'm just gonna read the question first. Draw a diagram. So it's like, for us, it's like for easy to like visualize, and then we'll solve it. This is like a really good method, especially if you're like, uh, not especially, it's like a good method for everyone, especially if you're like coding and all that, because it will like, next time you try to solve a question that is similar to this, you won't even have to draw a diagram because you have already practiced it so much. Your brain is already used to the diagram, so you can like draw it, like you can just like visualize it, and then solve the problem. So that's a really key part, especially even for like interviews. Always really good to like visualize stuff. So it's like really easy to solve the problem. Anyways, let's just read the question first. Okay. So the struct monster list maintains a list of monsters using a dynamically sized array of pointers to monster. A function prototype is given for function initialize monster, which takes in a pointer to monster that must already be pointing to a memory that is allocated. Okay. And then fills that memory with information about a default monster. Write a function get default monsters, which takes in a positive integer n, creates a pointer to a monster list, allocates room for it, and then fills it with n default monsters, and then returns a pointer to the monster list created. Note, you must call the initialize monster in your function. So as you can see, what the question is asking us, we are given two structures here. We're given the structure monster, and the second structure is monster list. And inside monster list, I will have a 2D array of type monsters. So what the question is asking us, hey, create memory for monster list. Let's call it ML. And then once you have created this like box, essentially, I will have a monster star star. Let's call it M array, and it will have int nm, meaning number of monsters. So what I want to do is first I want to dynamically allocate this box. Then once I have dynamically allocated this box, I need to create memory for the pointer of type monsters, right? Once I've done that, I will call the initialize function on each and every pointer and pass it the address here, and it will initialize the monster for us. We don't really have to worry about what it will like initialize it. We just need to create the memory. So question understood? Any question here? So
No.
let's call it ml star get default uh, monster, and it will take a parameter integer n, which represents the number of monster we will have, right? So the first thing is first, I'm just gonna create this like this the I'm just gonna create this like outer box. So and we'll just call it new. So the structure name is monster list. So I'm just gonna say uh ml star new. ML meaning like monster list. I'm just writing in abbreviations. But obviously when you're in the quiz or in the FE, you have to write the whole names. Equal to malloc size of uh monster list. Right? So now I have created this outer box. Now, once I have created the outer box, I need to fill in this and I need to initialize this memory. So let's do the easy part first. I'm just gonna say new arrow nm equal to the same thing as n, which is passed on to the function, which represents how many monsters we have, right? Once I've done that, uh, I will allocate space for this outside 2D array. I mean, for this, since it's a 2D array, I will allocate space for this pointer array of type monsters. So I'm just gonna do new arrow uh, m array, mar equals to malloc size of monster pdr, so monster pointer times n, right? Because we're allocating space for this monster pointer array. So once I've done that, I'm gonna run a for loop at this location and then initialize this with the help of the function that is provided to us, initialize monster. I just need to pass the address and then I should be good. It will just automatically initialize or like fill in this empty memory with like useful stuff for my video game or something, right? So easy. For int I equal to 0, I is smaller than n, I plus plus, and I'm just going to say new arrow m array at the ith position. Uh, oh, sorry, I need to allocate the, okay, yeah, I've allocated this space. Now I need to make space for the structure of monster, right? So m array at I equals to malloc size of monster. Once I've done that, now I can just, with the initialize function, I can just initialize this memory with useful information and then return the new array, right? So we init, call it new arrow m array at the ith position, and that's it. I only have to pass in the address. Once I'm done with it, I can just return new. Also, like a little bit tricky. Let me know if you have any questions on this one. No? This is like one of my favorite questions. Very good. Yeah, this is a really good question. This might take a while for me to like explain it. Okay, let's just read the question first and I will explain how it goes and then we'll try to solve it. All right. So the struct video games maintains information about video games that is stored in a store inventory. As a fan of the 1980s, you would like to get a list of all the games that were produced in between the years of 1980 and 1989 inclusive. Write the function below that takes in an array of type video game, its length n, and a pointer to a variable that will store number of games produced in the year 1980s. The function should return a newly dynamically allocated array storing a copy of all the information for the games that were produced in the year of 1980s and set the variable pointed to by ptr games to the size of the array returned by the function. This copy must be a deep copy where individual component is copied over, including allocating memory for for the copy of the same of the name and copying the name into the new memory. Very long question, very confusing question. Uh, if you haven't like solved this previously, you would definitely, and if you see it for the first time, this will take you a while to even understand what the question is even asking us, right? So let me try to explain what's going on. As you can see, the struct is just so let's say we have a struct, right? Let's say we have a struct. It has one, two, three. So it has character array called name, which is the name of the video game. Then it will have int year, which represents the year the video game was produced in. And then it would have a double, right? Which means the price of the video game. So in a store, the question is essentially asking us, a store has a lot of video games, right? So it will have like a whole list of this. A store will have a whole list of this. You as a programmer, it's your duty to as not no not your duty, but as a project, it's your duty to like create a new array and fill it with all the video games that were produced between the year 1980 to 1989. Because you just like the video games in that era, right? Hey, uh, so that is your duty. So this would be what we need to do here is we need to loop through this array, check, hey, if the year was produced between those years, I want to append it to my newly allocated array, right? So a couple of things like they have already solved the first part for us. They have created the memory. So they have created this like not memory, but they have created this, well, yeah, memory. They have created this empty array of type video games, right? They have filled it with nothing. It's our duty to like fill it with useful information. In this case, the video games that were produced in the year 1980 to 1989, and then copy each and every piece of information into this empty array, and then return this empty array back to the function. So they have what they have done is they have created this memory. They have given us a tracker, which is called ng, which is initially at zero, meaning hey, it's at the zeroth position. So what I'm gonna do is I'm gonna loop through this whole array, check if the video game was produced within those years, and if it was, I will copy it to my new array, which was created already for us. So pretty simple. So it'd be for int I equal to 0. I is smaller than number of games, or n, in this case, I plus plus, right? So what I'm gonna loop through this array, which was like contains all the video games information, and I'm gonna say, hey, if the video game, sorry, yeah, if the inventory at the ith position dot year is greater than or equal to 1980, and inventory at the ith position dot year is smaller than or equal to 1989, I want to append it to this empty array, right? I want to fill in the information in this array. So what I'm going to do is the simple part, I'm just going to fill in the year, the price, then I will fill in the name, right? So easy is like, it would be, what's the name of the array? Res, right? The newly, so res uh, at the ng position, which is 0 dot year, catches the same value as inventory at the ith position dot year. Same here, res ng dot price catches the same in catches the same value as inventory at I dot price. So I've copied the price and I've copied the year. Now what I want to do is, since here it is a character array which is dynamic, I need to allocate space for this array and then fill in this array with the name of the video game. So first of all, I'm just gonna say int len equal to string length of inventory at the ith position dot name. Now I'm gonna create space for this character array. Ng dot name equals to malloc length times size of character plus one. Plus one meaning for the null terminator, right? Once I've done that, I'm just gonna copy it. I'm just gonna call the string copy function string cpy uh, res ng dot name from inventory at the ith position dot name, and then ng plus plus, and then at the last position they have like reallocated the space for us, and the reason they have reallocated the space is because realloc can not only like increase the space of the array, but it can also like shrink the array, right? So in some cases it would be the case where like we have this video game array and it has only two games, right? It has only two games that were produced within the years of 1980 to 1989. But this whole array is the same size as like this one, right? So it wouldn't really make sense for us to like keep all this extra like garbage space. So we can like reallocate and make it the size of that is supposed to be. So we are not using extra space. So hopefully that question also pretty good question. Let me know if you have any questions. I can explain it. No, yes, no.